Okay, in this video, we're going to talk about the last of our three frameworks that we're discussing in this class, CRISP-DM. Now, CRISP-DM is the oldest of the data analytics life cycle models. It is from the mid 90s is when it was developed. And you'll see, though, that it very closely mimics the previous models that we have discussed, except that it has a main difference. Well, several main differences. There's two boxes that we haven't really covered in our previous frameworks, and there's a recursion, kind of a cycle process as well. All right. So the first thing we're going to talk about is the main thing that the other models may have not explicitly discussed, which is how do we take data and answer questions. Now, businesses, I use the term businesses, but whoever it is, whatever your context that you're working in, businesses or scientists or government have questions. Now, often these questions, the questions they ask are based upon intuition, and the answers that they come up with to those questions are potentially, and in most cases, dealing with intuition. Now, intuition might be good, but it also is likely that it's off. Now, how do we know? We do data science, right? We convert intuition into questions, and we answer those questions with data and modeling. And then we rinse and repeat. And so we end up, because of that rinse and repeat nature, we have this cyclical nature of analytics, where the first step in that process is the creation or acquisition of data. Now, it's not generally a problem to get to data. I mean, as far as that there is data, but as we've discussed in the other frameworks, making that data useful is kind of a problem, right? Then we explore the data again. The previous models have talked about that, as does CRISP-DM. Then we analyze, then we gain some understanding and determine the next hypothesis. And that's really the goal of any of these analytics frameworks. It's to understand and communicate what the data tells us is factual. I don't tend to use the term truth, but at least based upon the data we have, these facts can be supported, or these assumed facts can be supported. All right. Now, that cycle is what is reflected in this CRISP-DM framework. But the key difference is, you see, the business understanding box is new, and this arrow is new, going from the evaluation to business understanding, and there's this new thing called deployment. All right. So before we even start analytics, we need to know the business or the context question that is being asked, so that we can address the needs of the business. Before we begin doing anything with quote unquote data science, we have to understand, what's the end goal? What's the answer, right? Is it a categorization problem, a classification problem, or is it a quantitative result kind of problem? Why, right? Why are the subject matter experts? Why are the business leaders or the government leaders or the science leaders asking for these kinds of answers? And before you can really get to that point, you have to acquire subject matter expertise. Now, why do you have to do that? Now, the reason you have to do that is that you won't really know what realistic models look like without understanding the context. You won't understand that you really can't do this before this because some process must be followed, some regulation must be adhered to. So you can't model things that can't be completed according to what your model assumes, right? You also might think a model isn't performing well, but for instance, in a context where we've previously only been able to predict, let's say, 5% of bad loans for a particular category of customer, and we've now with our new model, we can predict 30%. That's actually a significant improvement. And although, yeah, it's still pretty much cup half empty, it's certainly a major improvement. All right. Now, I just want to map what CRISP-DM does in comparison to what OSEMN does. Now, there's pretty much a one-to-one relationship between the two methods or the two models. All right. So we have OSEMN at the top, where we have the obtain, scrub, explore, model, interpret. And realistically, obtain has to do with, on the CRISP-DM side, data understanding kind of maps with obtain. I understand what the data is that I need. I obtain the data. I understand what I have. Scrub and data preparation are nice and congruent. Now, OSEMN makes much more explicit discussion of exploration. Like once I've got my data, now I need to explore it. Although in CRISP-DM, exploration is really kind of at the front end of the modeling component of that box. All right. And then finally, we have interpret and evaluation, which are also pretty congruent. But the really neat thing that CRISP-DM covers that OSEMN does not is the cyclical nature of the data analytics lifecycle. That when we get to our first evaluation, we might have to go right back to the business people and say, this happened. This is what we see. What do you think is the reason that our model looks like this, or that our results look like this? How can we more clearly ask the question of the data and then go back through the process? And you might do this 50 times. Now, hopefully you don't have to do it that many times, but you can do that as long as you need to. And the final component of CRISP-DM that isn't covered in OSEMN is the idea of deployment. And once a model is verified and evaluated as to be the appropriate model, the best model, the model we want to put in production, that gets locked and put into production and deployment. And so if you think about it, you'll do the cycle of creating and testing new models all the time, but you'll deploy rather infrequently in comparison. And once you deploy is when your model is actually predicting. Until then, you're working with historical data, you're working with test data, you're working with holdback data, and that data is from the past. It's going to train your models. It's going to help you to put the right model, the right independent variables into your model to understand your dependent variables. And then once that model is ready, you deploy it to production and you move on to the next question and go through this cycle 30 times and then deploy again. All right. So I'm not going to really go into a ton of detail. There was the reading on CRISP-DM that I do want to make sure that you do. What I'm just trying to make you understand is that really all of these different models that you're going to see out there in different contexts end up being the same basic process, which is the idea that I have a business problem or a context problem that I want to answer a question about. I go get data. So I have a needs evaluation for what data I need. I identify where that data is and I get it. I cleanse it. I prepare it and get it ready for analysis. I do a step that involves understanding what the data looks like and whether it meets certain assumptions, whether there's hidden patterns in the data, etc. Then I do my modeling. I'd interpret that model and I do some reevaluation, and I do that cycle as many times as possible, and then I deploy. All right. All of these frameworks that we've talked about, the data analytics lifecycle, OSEMN, and CRISP-DM, really reduce to this process. All right. The important thing that you need to be comfortable with is the fact that it is a cycle, and the fact that it is to some extent educated trial and error. And you have to be very comfortable with the idea that your analysis will not be done the first time through. And a lot of people have a problem working that way, that they have this expectation that if I didn't solve the problem, I failed. And that's not the point. The point is not to solve the problem in every cycle. It's to gain better and better understanding so that you can best solve the problem over time. All right. So that's kind of the differences between CRISP-DM and the other frameworks is its real understanding of the cyclical nature of data analytics projects. And there is no problem with having to go through the same process 15, 20, or more times. And that is typical in science. It's typical in data science. And so you should be comfortable with that. But what I really want you to understand is that no matter whose model you pick, this is basically what's happening, right? You have data. You have a whole bunch of time spent on that data. You model, you interpret your results. You either have the results you want and you deploy, or you reevaluate and you go back to the business and say, this model didn't really work. What should we do to improve it? Why didn't it work? All right. So this is the place we want you to be. There's 3 frameworks. CRISP-DM is the one that's kind of the most formal. And that's why I have you actually read about it. But they all break down to this basic idea. All right? Great.